G'day guys, today I've just got two trig problems. It's the last day of trigonometry for us. We've probably got as far as we can with the online learning. So on Monday, I think Mr. Bell's going to do an introductory lesson on coordinate geometry, which will be another small internal for us to do. So what I'm going to get you guys to do is calculate the difference in the areas of these triangles. So this triangle DEF is 51 millimeters, 54 millimeters, and 45 millimeters, and XYZ is 5.1 centimeters, 6 centimeters, and 73 degrees and 54 degrees. So we want to calculate the areas. So you could pause the video now and give that a go. So area of DEF, we'll do this triangle here first. Well, the first thing that we need is we need a angle, don't we, so that we can use the area formula, which is a half BC sine A. So what would be a good angle for us to find? I think I could pick any three. I'm just going to go for this angle here. I'm going to call it angle theta. So cosine of theta, remember your cosine rule finding a side, is going to be b squared plus c squared minus a squared. So 45 squared plus 51 squared minus 54 squared all over 2 times b times c. So hopefully you've got that far, right? Finding one of those angles. So I'll get my calculator out and I can just chuck that in. So turn it on will help. 45 squared plus 51 squared minus 54 squared on the top. 1710. Over and on the bottom we have 2 times 45 times 51, 4590. And then if we just want theta by itself is cosine inverse of that fraction. So shift cosine, and I'm going to plug that fraction in. 1710 divided by 4590 and 68.1 degree. Okay, that is that angle there, 68.1 degrees. And now I can calculate the area really easily. So now I can go a half times b times c times sine of that internal angle. So I've already got the angle stored in here, so why don't I just sine answer. Cool, I've sine answer there, I've decimalised that angle, times it by 45, times it by 51, and times it by a half, and I get 1064.9 millimeters squared. So I've actually got the units in my answer. So that bottom half of the page is my working for calculating the area of this triangle here. So I use this formula, half BC sine A. I use the cosine formula from the previous video to find the angle so that I could then use the area formula over here. Notice that the units are different, so we want to make those units the same. So we want to make this 51 millimeters and 60 millimeters. And we can go straight ahead and use the area formula, but what we do need is we need the angle in between those two sides. So I'll just take the total angle inside a triangle and minus the other ones. And I'll probably show my working on paper if I had a bit more room. So that's going to be 53 degrees. And so the area of x, y, z. That's just going to be a half times the adjacent sides, 51 times 60. I want this in millimeters because I need them to be the same, times sine 53. So if I go sine of that answer, because I had 53 in there before, times it by 60, times it by 51, and then times it by a half, I'll have 1221.9 millimeters squared. And I always get to a point like this where I think I've answered the question, because I go, right, I found the areas of both those triangles, and that's what I told myself to do in my head. But what you need to do is you need to go back and read that question, calculate the difference. So what's the difference in those two areas? Well, the difference is just the one minus the other, and you usually just do the largest one. It doesn't matter if you get a negative though, because that just take that as a positive number, and that's your difference. So 1221.9 minus 1064.9, and I'll need a calculator for that. Luckily I've already got it here, so I can just get the answer, take away 1064.9, and that is 157 that's 0 millimeters squared. Hopefully that's still in the camera. So that is the entire problem there done. Cool. I got one more for you. It's based on circular measure, and it's this one here. I'll just align that so that it's in the camera nicely. So I want us to figure out the area in here, and all you have is that information. So this length here is 60 centimeters, that's 25 centimeters, and that is 70 centimeters. So the shaded area, I want you to give that a go. All right. The first step is we want to find this angle. Because we have a radius and an arc length, we can use this formula here. S is the radius times theta. Remember, that's in radian measure, so that's going to give us the number of radians in here if we were to solve this. So 70 is equal to theta times 60. So if we were to rearrange that, we would get theta is equal to 70 over 60. So 7 over 6, if we simplified that. 7 divided by 6. In radians, that is 1.16 recurring. Okay? Now, that was all well and good. We've got this angle here, but it was this one that we want, don't we? Now, can you remember how many radians is in half a circle? It's pi. So this angle here in radian measure would be, so we'll call this theta, I'll call this beta. So beta is going to be pi minus that angle. So pi, take away that angle, will give us this. So if I keep this in my calculator, and I go pi minus that answer, beta is 1.97493. I want to just kind of keep it accurate. Maybe 4 dp is probably all good. Let's go 4 dp, should be fine. And now I can calculate the area of that. So the area of a sector is in radian measure, theta r squared. That's why these formulas are so nice. We don't have to take a fraction of a circle or any of that. We just use the radian measure times by the radius squared. So 1.9749 times the radius of this one squared. And what I'll do is I'll keep this answer from my calculator to just keep it as accurate as possible. So I'm just going to go hit times, and I'll automatically do the answer times 25 squared, which is 625. And the answer is 1234.3. Units are centimeters, and it's an area, so they are squared. And there you have it. That is the area of that shape there. So a problem that looks pretty tricky at first actually comes out to be quite simple. So the key step in there actually was you're all quite capable of just rearranging that formula for the angle in radians, but it was just understanding, just remembering that a half a turn, right, 180 degrees, that is pi radians, okay? And so pi minus that angle will give us that remaining angle in there, and then we can easily calculate the area of that shaded side. So comment below if you think that went well, or if you want me to go over another problem again. Awesome.